Thank you. So, 2 talks about web components in the same conference. I think they're finally becoming mainstream. Hello everybody. Thank you for having me, and thank you for your time, and thank you for the chance to talk about web components. Thank you to the organizers and everybody. So before we get started, just a very small amount about me. So as I was introduced, my name is Revill. I'm a web architect, and I work for a company called Common Time in Derby, where Lara Croft was born, in England. As also mentioned, I'm also a Google developer expert for web technologies, co-host on the Web Platform podcast, Plural Site author, which my most popular course is on web components. And I'm also a blogger where I write a lot about web components, share explanations and use cases and examples and those kind of things. So I want to be very clear on what this talk isn't, and it's not a talk about how you should replace frameworks with web components. I think that's you can totally do it. In fact, I use web components and not frameworks quite a lot of work. But I also think there's a really good use case for using web components with frameworks. Today we're really fortunate to be inundated with really well-designed JavaScript frameworks that make it much easier to build like large-scale JavaScript applications. And these frameworks make this possible by solving some common problems. Common problems like state and UI synchronization, client-side routing, server-side rendering even. They also enforce best practices. They provide a great tooling experience, so it's really easy to get up and running, or just generally help test and all those other kind of nice things. They foster a great community, and as all of you here know, I'm sure the web development community is really amazing, and frameworks help a lot with that. And also, most of the modern frameworks, they also provide a solution for making it really easy to build user interfaces, and mostly around components. But I think it's in this particular area where we can choose to use web components instead of framework components to gain some really significant benefits. So during this talk, I hope to convince you that thinking about using web components instead of diving straight into using framework components is absolutely worth your time. Hopefully going to show you some of the reasons why web components provide some great benefits working with frameworks. But before we get into why and how web components solve some problems and what the benefits are, I think it's really important to fully understand exactly what web components are. So, web components, originally 4 specifications were proposed to make web components a reality, and those 4 specifications were custom elements, shadow DOM, HTML templates, and HTML imports. And these specifications were proposed quite a while ago, and since then there's been some new best practices emerged and new patterns for creating web components, which kind of leave us focusing mostly on the first 2. HTML templates, where they're incredibly useful in their own right and can still be used to build web components. Because of some new JavaScript features, we're no longer actually reliant on that particular technology. HTML imports, still heavily used by Polymer, but unfortunately it's a bit contentious because, for example, Mozilla, Firefox, they said they're not going to ship that particular specification. It's also not supported in Safari at the moment either. So today, mostly when we build web components, we're really talking about custom elements and shadow DOM. So I think it's important just to look in a little bit of detail as to exactly what each of these specifications provide us as developers. So custom elements basically allows developers to create their own DOM elements. And let's just have a little look at exactly how we do that. So touching on what was spoke about earlier in the previous web components talk, you can create your own custom DOM elements basically by using the JavaScript class syntax. So here is a very simple example. I've called it hello name element, and it extends the HTML element interface. So the HTML element interface, this is the interface which all built-in DOM elements ultimately inherit, and by built-in DOM elements I mean like H1 or paragraph elements, input elements, etc. And this interface houses all of the expected properties you would expect to see on DOM elements, such as offset top, client width, and inner HTML, those kind of things. So by extending HTML element, we get all of that built-in functionality for free. And then we can just use it like a normal class, so we can use the constructor or define local variables. Here I'm just defining a really simple local name variable and assigning it an empty string. So we can also create our own custom templates for our custom DOM elements. Here I'm declaring a really simple template. It's just a paragraph element with some text in it, and it's going to output the value stored in the local name variable. So it's just going to say hello and then whatever name is stored there. The custom element specification also provides a range of render lifecycle callbacks, not too dissimilar from many of the frameworks. So you can do things like detect when the element gets added to the DOM, when it gets removed from the DOM, and various other things. So here I'm just using the connector callback, which is executed when the element gets added to the DOM. So I can call the render method and just stamp that template into the DOM. Also, like framework components, you can also define properties. With the ES6 syntax, we use getters and setters for that. So here I'm just declaring a simple name property. And this is just so from external JavaScript, we can update the local name variable with a new value and re-render the template to display the new value. We'll see how that works shortly. So we can also listen for attribute changes, and by attributes I mean DOM attributes, so like the disabled attribute on a button or the value attribute on an input element. So here I'm just listening for any changes to the name attribute on this custom element, and it's just another way to be able to get data into the component, another way of specifying a new name to be rendered in the template. And then once you've basically defined all the functionality for your custom element, you need to tell the browser about it. And we do that using the define method, which is available on the custom elements object. We then give it a tag name, the tag name being how we refer to it in HTML. And the specification, the custom element specification, dictates that we must specify at least one hyphen, and this is to distinguish between built-in DOM elements and custom elements. Obviously, if you'll notice, all built-in elements don't have a hyphen in them. And then you specify the interface for your new element, which is the class that we created earlier. And then you can basically use it in HTML just like any other DOM element. So I'm using it in a really simple page here alongside a H1 and a paragraph element. I've also specified the attribute, the name attribute, and then giving it a new value. So ultimately, when it gets rendered, it's going to say, hello, Leon. And also because we specified a property. Again, because custom elements, they just work like DOM elements, we can interface with them in exactly the same way. So I can use a query selector to select that particular element, and then I can update the name value just using dot notation to update the property, and then ultimately that'll call the render method and re-render the component. And that's probably the fastest explanation of custom elements I've ever done. But the whole point is that custom elements make it possible for us to create UI components that have got a well-defined interface that just work like DOM elements, work in a very familiar way. They can also have custom templates and various other things as well. So Shadow DOM, the other important specification when it comes to building web components, and the Shadow DOM basically allows us to create an encapsulated sub-DOM tree for our components. And by encapsulated, I mean that our templates are not going to inherit global styling from the application, and also we get some protection from DOM manipulation as well, and we'll see how that works. So to get this encapsulation benefit, we need to create something called a shadow root. And we do this simply by calling the attached shadow method on the element instance. So here I'm just doing that in the constructor. And then instead of placing the template as direct children to the custom element itself, we then need to place that template inside this encapsulated sub-DOM tree. And we do that by using the shadow root property, which is available once you've done the attached shadow method. And again, you can just use inner HTML to put the template inside that shadow root. So now if we were to go ahead and actually render this in a browser and look in the developer tools and look at the DOM Explorer, you would see something like this. So as you can see, as like children, as a child to that particular custom element, we have this new shadow root, and the template it was in there is inside the shadow root, and that's got some significant benefits. So first of all, it provides the style encapsulation that I mentioned. So if I was to use my component in a page like this, so it's really simple. It's got some global styles where basically we're just setting all paragraph elements to have a color of red. And as you can see in the render below here, as you could expect, the paragraph element in the main document has inherited that style and is red. But if you remember, even though we've got a paragraph element inside the components template, it's not inheriting that styling because we're in this separate subdom tree. We've got this encapsulation. And equally, if I went back and updated our template to include some styling of its own, so here we're adding some styling to the component in itself, where we have a paragraph element, and we're setting all of the paragraph elements to have a color of green. As you would expect, we now get the green coloration on the paragraph element inside our template, because that's where the styling is. But also, we don't interfere with the styling of the main application. So the main application's styling stays intact. And this basically gives web component users confidence that when they include a web component into their page, it's not going to break the styling or break the aesthetics of their application. And equally, as web component authors, when we spend ages like making something look really nice, we know that no matter what styling the user's got in their application, we know that our component is going to look like it intended to. And also, because of the shadow DOM, we get some benefits in terms of protection from DOM manipulation. So in the same page, if I was to run some JavaScript like this, so query select all, basically to select get references to all of the paragraph elements in the document, it's only going to select the paragraph element in the main document. It's not going to automatically go into the shadow root of my component and get a reference to the paragraph element there. So if there's any JavaScript libraries or anything in the main application that's doing some kind of sweeping DOM manipulation, we know that we've got some protection from that as well. We know that our functionality is going to stay intact. So the shadow DOM then, it basically allows us to create fully true encapsulation for our components, so that as web component users, we know that it's not going to, when we include a web component in our page, it's not going to break our app, and we also know that the styling isn't going to affect the look of our app as well. And as web component authors, we've got the confidence that when somebody uses our component, it's going to work as intended. There's also some other really good benefits of Shadow DOM, which unfortunately we don't have time to get into, such as slotting. So I really would recommend that you go and take a look at this specification, learn a little bit more about it, and see what other features it has available. So even though web components have been in the making for quite a while, they're still relatively new, but it's really good news that both Google Chrome and Safari have had web component support for quite a while. As of this month, I'm not sure exactly when Firefox 63 is going to be released, but that is going to be shipping with full web component support, apart from HTML imports, like I mentioned earlier. Of course, unfortunately, Microsoft Edge is lagging behind a little bit, but they've even promised us web component support for quite a long time. But the important thing is that they're dedicated to giving full attention to the web component specifications. They want to get full support, and they're going to do it as soon as they're able. And of course, our old friend Internet Explorer isn't going to get any updates anytime soon. But for those two browsers which don't support web components, we do have some polyfills which are very reliable, and they can ensure that our web components work across all of the major browsers. So to summarize then, what are web components? So they're a way to build truly encapsulated UI components. They've got a well-defined interface. And they work just like DOM elements, so they work in a very familiar manner. As JavaScript developers, we're used to interacting with DOM elements, and they work just like that. So there's no new strange syntax really to deal with. It's very, very familiar. And because web components are built on web standards, they don't rely on any framework or JavaScript library. So both custom elements and Shadow DOM, obviously, they're built into the browser. We don't have to include any JavaScript libraries to get all of that functionality. It's already available to us. And because web components are built using those technologies, available and built into the browser, they're framework agnostic. So we're not tied into any particular technology. So earlier, we outlined some of the reasons why we use frameworks. So they make it much easier for us to build large-scale JavaScript applications. And we also mentioned that they provide a solution to building UIs. Well, and I basically said that we should think about using web components in that area because there's a big difference between web components and framework components, and that is that framework components are not interoperable, and by that I mean you're not going to use a React component inside of Angular or vice versa. I mean, you could do, but you're probably not going to. So framework components are really good for reuse in their own ecosystem, but anything outside of that, they're not, so you can't reuse those components easily across multiple front-end stacks. I think that's a problem because more than half of developers use more than one framework. Out of the 24,000 people, I think it was, that took the State of JavaScript 2017 survey, 53% of them said that they use more than one framework, and I'm sure there's plenty of people here who have used, worked on multiple projects, working on multiple different frameworks at the same time. So that is obviously a problem because what happens is we end up having to re-implement components multiple times, one for each framework that we utilize. And that basically means that we have to maintain multiple sets of code, which obviously leads to more chance of bugs. It's a maintenance headache, and it takes longer to add new features and fix bugs if we're having to work across these multiple versions of the same framework, same component, sorry, in the different frameworks. But with web components, if we think about writing some of these common UI components as web components instead of framework components, then we've got some significant benefits in the sense that because they're framework agnostic, they'll work across multiple frameworks with no problems, which means we can write them once and just use them everywhere. And that has the obvious benefits of we're maintaining a single set of source code for that component, will lead to less chance of bugs, there'll be less time wasted, and most importantly, we can focus on building one thing and building it well instead of trying to juggle multiple versions of the same thing. But also, even if you aren't basically utilizing multiple frameworks at the same time, the interoperable nature of web components has got some real benefits. Because web components are built on web APIs and are not stuck into any particular framework, they're interoperable. You've got a lot more flexibility because when you want to choose your next framework, you don't have to weigh up the possibility of needing to reuse some components you've already created, and that might dictate as to which framework you choose next. But if you've written your UI components as web components, then you know they're going to work in whatever you choose, so you've got more flexibility in there. And also, if you need to migrate a current project, again, because your web components are going to work in whatever framework you choose next, that migration is much easier. And then if you have to do any large upgrades, so if anybody went from Angularjs to Angular, they'll know the pain. Of course, if we chose to use web components instead of Angularjs directives, things would have been much simpler. And because of these 2 points, there's less chance of getting stuck into a particular framework. So there's less chance of getting stagnated by a technology that you're finding it difficult to get out of. And maybe not so obviously, because web components are independent of frameworks, you can develop and test them in complete isolation. And that opens the doors to new tools, new libraries, new technologies and methodologies that you might have not had available to you because you were tied into a particular tool chain. So hopefully there's some compelling reasons to start thinking about web components and realize that because of the interoperable nature of web components, you've got much more freedom in your front-end stack, and you can take some of those common UI components that you use a lot and invest in them instead of having to re-implement them or change them as you kind of migrate different frameworks. So how do you actually use web components in some of the more popular frameworks? Well, the good news is that most frameworks love web components, and they make it really easy to actually integrate with them. So there's a website called Custom Elements Everywhere, and this website was created by Rob Dodson, who's a developer advocate at Google. And this website basically details how compatible certain frameworks are with web components. So each of the frameworks that are listed, I think there's 15 on there at the moment, a series of tests have been written, and then a result of these tests basically generates a score that looks pretty much like this. And you can see that even with the recent versions of Angularjs, even Angularjs has got a compatibility score of 100%, which is really good to see. So I think it's worth just spending a little bit of time and just looking at some of the more popular frameworks and seeing how you actually use web components in those. So who here is Vue developers? Anybody use Vue? Yeah, cool. So Vue is one of the frameworks that also has a 100% compatibility score, which is really good. So let's have a look at exactly how we use web components in Vue. So the first thing we need to do is actually import the web component. So this star rating web component is just a really simple star rating component. And inside that JavaScript file, there's the class definition that we saw earlier, and also the call to the define method on the custom elements object. So we need to import it basically just so the browser knows about it and we can actually make use of it. And then with Vue, we have to do a little bit of configuration. So we basically have to tell Vue to ignore our custom element tag name. And that's so that, because if we didn't, Vue would basically look for a Vue component with the same tag name, and obviously it wouldn't find one. So by telling Vue to ignore our custom element tag name, it'll just drop back to using the custom element, and then we're able to use it. And you just do that by specifying it under this ignored elements array in the Vue configuration. And then you just go ahead and bootstrap your application, and then you can just go ahead and use it like you would any other Vue component, really. You can set properties and set attributes. You can also listen for events, and all of the kind of stuff that you'd expect. So Vue really makes it very, very simple to use web components. It's a small amount of configuration, and then you use them just like any other components. Angular, how many Angular developers do we have here? A few more, I think. So Angular is another framework which has got a 100% compatibility score with custom elements, which is really good. So let's take a look at what we need to do to use web components in Angular. So first of all, we need to import this custom element schema from the Angular core module. And then we'll look at what that does shortly. And then, of course, again, we need to include our web component. So again, so the browser knows about it, so we can actually use it. And then in the ng module definition, we need to specify this custom element schema, which we imported. And that is very similar to how we kind of set up Vue. It basically allows us to use non-Angular elements in our templates, non-Angular elements that have got a hyphen in them. And if you remember that custom elements are required to have a hyphen in their tag name. So that just basically allows us to use custom elements in our templates. Very similar to what we did with Vue. And then again, similar story, you basically just use the web component like a normal component. You can set properties, set attributes, listen for events, all that kind of usual stuff. Again, Angular makes it very, very easy for us to use web components. And then there's React. So unfortunately, out of the 15 different frameworks that are currently listed on custom elements everywhere, React has actually got the worst score out of them all, even worse than Angularjs, for God's sake.
Yeah, because I believe React is overreacting on so many much things. It is a big shame because React is probably the most popular. So how many React developers have we got here? Oh, don't know, maybe about the same as Angular then, so maybe not, but it's such a shame. But the good news is that React does pass all of the basic tests. So that means that basic integrations with web components is really, really easy. In fact, it's actually a lot easier than it is with the other frameworks we just looked at because there's no configuration needed at all. You basically import the component, and then you can use it in your JSX templates. Just like you would any other DOM element. So you can do really basic things like set attributes, etc. But where it gets more complicated is basically because React passes data to custom elements as attributes and not properties, it means that you can't pass complex data. So you're fine with strings and simple data like that, but if you pass down an object, you just get object in square brackets, which obviously isn't very useful. And additionally, React has got its own synthetic event system, so you basically can't listen for custom DOM events on custom elements either, which obviously makes interfacing with with custom elements and web components quite difficult. There is a workaround which is not that bad really. So the way that you do this is you use Reax Ref System, so you can basically create a reference to the element, to the web components, and then you can use that reference to do things manually, like manually calling add event listener, manually setting properties, or anything like that. So it's not too bad. It does mean that we can gain more from web components in React. The good news is that there's loads of interest in making React better at integrating with web components. There's lots of community interest. There's also been some solutions provided by the community, solutions that the React team are actually on board with, and these solutions have been passed through React's request for comments like proposal system. So really it's just a case of waiting for these solutions to be adopted and released in a new version of React. So overall, things are looking pretty good. So hopefully by now we've seen that there are some compelling reasons to use web components. We've seen that most of the frameworks make it really easy to actually use web components within them. So kind of where do you start? Where do you start if you start to look at using web components? So if we go back to my first example, and I know you can't see that, that's not a problem. You might have thought, well, that's quite a lot of code to do something really simple. I mean, all I'm doing is outputting, hello and then a name. I mean, and there's a lot of code there, right? And I would totally agree. We had to create the shadow root. We had to then manually place the template inside the shadow root. And for anybody who's concerned with performance, you would have noticed that this is really inefficient. Basically, every time we call the render method, we're re-rendering the entire template, which really isn't good. Fine for a really simple example like this, but anything more complex, it really wouldn't be a good idea. We had to listen for when the element gets added to the DOM and call the render method. We had to set up the properties, quite complicated, but then we had to do things like check to make sure that the value being passed in is actually different to what's currently stored, and then call the render method. Lots of stuff going on here. Manually keep track of attributes. Lots of stuff going on. Now, the good news is that the web component community and ecosystem is already really big, and there's loads of great libraries and tools to make building web components much, much easier. So to name some of the more popular ones, you've got Polymer, which is a mature web component library from Google. There's Skate.js, which is a really lightweight web component library. It's got lots of features like interchangeable renderers and those kind of things, so you can use Preact within it, or some other like virtual DOM implementations. There's Stencil, which is like a web components compiler. And one of my favorites, which is what I'm going to recommend that you take a look at, is LitElement. And basically, like all of the libraries we've just listed, LitElement takes what we previously had from something like this to something much, much simpler. It really abstracts away a lot of the complexities and makes it simpler to write. So let's have a little look at how that kind of does it. So instead of extending HTML element, if you're using LitElement, you would extend LitElement instead. Then you can basically create properties on a component using decorators. And this automatically syncs the properties to attributes if required, and it also automatically calls the render method, so we don't have to do any of that manual stuff at all. The render method is where it gets really interesting, because LitElement utilizes something called LitHTML, which is a really lightweight library for making super fast DOM updates. And it utilizes some new web platform features that allows us to perform DOM updates as fast as, and it often outperforms virtual DOM alternatives. And because it's using web platform features, it means that LitHTML can do this in much fewer lines of code, so it keeps the library really, really small. So not only does LitElement with LitHTML kind of abstract away a lot of the complexities, make it really easy for us to build web components, LitHTML has got some features of its own which are available inside the templates, features that are very familiar when you're used to building components with some of these frameworks. So obviously we can render text. This isn't a LitHTML feature, this is just a JavaScript string literal. But there's some other features, like it makes it really easy to set attributes, including Boolean attributes. We can also easily set properties from within the templates. We can also easily listen for events inside the templates, very similar to how you do with Vue and other frameworks. And it also allows us to do loads of other more complex things like iterating over data. You can even use promises directly in the templates. And there's loads of other features that LitHTML provides. If you just go on the website, you'll see loads of things. But it basically gives a lot of those features that you're used to using if you're building framework components. So because of that, I really recommend looking at LitElement and LitHTML. Again, it abstracts away a lot of the complexities for building web components, makes it easier, and gives us some of those features that we would expect to see when we're used to building framework components. So hopefully at this point, you've seen some of the things that make you think about wanting to look at web components. The summary is that I still think that frameworks are very, very useful. Again, I mentioned that I often don't use frameworks at all, but frameworks do make it really easy to build scalable applications. They solve a lot of the common problems like state and UI synchronization. They make it easier for server-side rendering with tooling and those kind of things. So frameworks are awesome, but thinking about writing your common components or a lot of your components with web components instead of framework components, you can gain some really significant benefits because of the interoperable nature of web components. If you're using multiple frameworks a lot of the time, then you can save time and create less bugs by choosing to use web components. And even if you're not, because of the interoperable nature, you gain loads of benefits. Flexibility when it comes to choosing your next framework, flexibility in migrations or upgrades, basically less chance of getting locked into a particular framework. And the way I like to think about it is I like to think about writing web components means that your components have got like a long life, because at the moment, if you write framework components, you can tend to basically give your components a certain lifespan until you kind of move on to a different framework or something. So if you write web components, then because they're going to work in no matter what you choose next, you can kind of invest much more in those components and spend time making them really efficient, and you know that you're going to be able to take them with you. Who knows, like maybe they'll outlive you. And the good news is that most frameworks love web components. They make it really easy to integrate with web components. So there's no excuse to kind of give it a go, really. And for a place to start, I'd recommend taking a look at LitElement and LitHTML. That abstracts away a lot of the complexities, making it really easy to make web components, and also provide some of those features that you're used to using when you write framework components. And just thank you for listening. Hopefully I've convinced you to, thank you. Hopefully I've convinced you that you'll actually spend a bit of time and look at web components. The fact that there's been 2 talks on web components in this conference, I think there's absolutely no excuse. So thank you very much, and yeah, thanks.
Okay, Okay, Leon, thank you for the great speech, and we also have a few questions from the audience.
I'll do my best.
And the most popular one is how to deal with styling external web component if we want to adopt it to our project style system.
Right, so I assume that means you've already got a load of styling in your applications, and then you want to write some web components, and you want to make the most of the styling you've already got. So you want to be able to basically theme components. I'm going to take it as that. So this has been probably one of the biggest questions, or one of the biggest reasons why you wouldn't use web components, or people's arguments for why they won't use web components. And the immediate answers are you can do some slightly hacky things, like just making sure you inject and include the templates inside your your CSS files inside your web components. So then those styles will actually get applied inside the shadow root. But there's a much better solution, which is a new specification which is going through the proposal system at the moment, called CSS shadow parts. And this basically will allow web component authors to choose particular parts of the template to kind of expose externally, so that the applications can selectively style and theme particular parts of that component. And there's already a polyfill available for that specification, so you can actually go ahead and use it now. It's just not available and implemented in all the browsers yet.
Thank you. Okay, thank you. And next, I believe I'll merge two questions into one. Because is there any news about server-side rendering for web components? And the second part would be, what about search engines? Do applications have problem when indexing?
Yeah, so they kind of come like all together, really. So in terms of search engine optimization, then the best bet, I think, in my opinion, really is to server-side render them. Not just for web components, but server-side rendering JavaScript applications really provides loads of benefits for browsers, not only for indexing and the speed and everything. So server-side rendering components is another one of the reasons why people have kind of put off from using web components. And it's still relatively new because it's quite difficult to server-side render web components that utilize the shadow DOM. But the best thing to do, I think, is take a look at the work that Trey Shugart is doing. So Trey Shugart, he's the author of Skate.js, one of the libraries I mentioned earlier. And he's done a lot of work on making it possible to server-side render web components that utilize the shadow DOM. So if you look at Skate.js/SSR on GitHub, you can see a library and a project he's working on there to make this possible, which also provides loads of other benefits. Not only does it make your web components SEO compatible and allow you to do all the server-side rendering stuff, it also means that you can test your web components a lot easier because you can use this server-side rendering library to help with that as well. So that's the best place to look. So that's Skate.js/SSR, I think it is.
Thank you. And okay, third question. I need to choose it. Yeah. So have you used web components in real project? And if yes, what problems you've faced in this?
Real projects, right. So it's got a lot. So I'm kind of lucky in the sense that at work we build mainly mobile applications that just like hybrid applications that run on Android and iOS, which means we don't need polyfills at all. So we work on platforms where there's full web component support. But previously, when you've got to support a more wider audience and like support IE and some of the other browsers which don't currently support web components, you can come along some quirks. Come across some quirks in the polyfills, etc. So the kind of main one being that if you use the shadow DOM polyfill, but it's called shady DOM because you can't really fully polyfill the shadow DOM, so you have to do some additional stuff in your components, like write a few lines of code in your components to make sure you get the style encapsulation. And there's also a few quirks in various other polyfills across the different browsers. For example, if you need to ship ES5 code, because you maybe support like IE11 or something like that, there's not a problem, but like a quirk in the custom element specification where it won't let you provide ES6 classes, so you have to add other shims and stuff like that to get it all fully working. Nowadays, it's all pretty well documented, so just a few searches online can kind of help with those kind of things. But they're kind of common problems that I think people come across. And if anybody else has any common problems that they want to chat to me about, maybe I've got some solutions, maybe I haven't, but please come and find me afterwards and let's talk about it.
Okay, yeah, as we mentioned, you can find Leon on the first floor on the speaker corner, so I believe we can thank him for his awesome speech and performance.
Thank you very much.